Good afternoon to all of you. Thank you very much for joining our last lecture. So today I would like to continue with boundary value problem. This is the last topic. Okay, we agree to teach to all students for all sections for this semester until ODE BVP. So we not touch PDE. Okay, so leave it PDE, no project about PDE. Okay, last week, that is your final project. It means that project number 2. Okay, so clear. Eh? So our target now is finish BVP today, and then we'll recall about the test 2, okay, topic, numerical differentiation, numerical integration, and computing, IVP and BVP. So our test 2 is on 17th of June 2021. Yeah. Hopefully all of you have the good health, okay, condition, no quarantine condition, okay, preparing everything to finish this course test 2. Okay. So now I would like to share the BVP. Okay, can you see? Okay. So if you look at our module, okay, is basically topic number 9. Okay, topic number 9. So we call as a boundary value problem. So it's actually from ordinary differential equation. So subtraction, boundary value problem. So last week about initial value problem. Okay, why we need to learn? Okay, why we need to learn about BVP? Okay, there is a many application. Initial conditions are not known at a single point rather than different value of the independent variable. Sometimes it is more convenient to observe certain types of condition at different time rather than all the type at the same time. Okay, last week I mentioned about the IVP. Okay, you only know the condition about the initial. Okay, but the problem for initial, okay, they don't want you to know the specific location. Okay, because initial boundary problem, okay, has limitation of analysis. So when the problem want you to know the specific condition, it means that different time, okay, observe specific location, specific length, okay, we need to use a boundary value problem because it is easier to observe and record the specific condition, including displacement, length, okay, angle, okay, at 2 different times than to record the others dependent value. Okay, and of course we know that many physical problems are better or can only be formulated as boundary value problem. So this is more realistic when you use BVP compared to initial value problem. Okay. So this is the example of ordinary differential equation. So as we know, ordinary differential equation, okay, can be represented as, okay, this is equation of ODE. Okay. So we can solve this problem via IVP or BVP. Okay. So you need to know the condition. You need to know the condition. For example, okay, this is the conservation of energy, develop a heat balance for the long, okay, thin rod. The mathematical modeling for ODE is like this. Okay. Then we know H is the heat transfer coefficient, Ta is the temperature of surrounding air, and so on. So with boundary condition, the statement of the problem, okay, such as with these two boundary condition, equation 1 can be solved analytically using calculus. Okay, if we use boundary condition, so we know that at the initial and the end point in between, we would like to observe what happened in between for this long and thin rod. Okay, so if we have this rod, so this is initial. Okay, this is the end point. So for initial, we only observe initial. If boundary condition, we have 2 points. Okay, initial and end. So it's more easy to solve what is the condition in between this initial and end. So for example, we put this is point number 1, this is point number 2, this is point number 3. Okay, instead of you only have only one initial point, okay, you don't know what is the value for end point, but you need to explore point 1, 2, 3. So it's difficult. Okay, if you have boundary condition, so you have initial value, you have endpoint value, you only need to use differential equation using specific formula, which means central finite difference to observe and determine this specific point. Okay, so when we use a boundary value problem for the specific method, that is approximate method. Okay, before we know the approximate method, we actually solve using analytically. It based on calculus. Okay, it based on calculus. So now in this course, we don't care about the calculus, but we need to use the approximate method that I will introduce you today. Okay. So this is the schematic diagram how we want to understand the ODE BVP. Okay. So the first figure shows the initial condition only. This is IVP. This is BVP. Okay. So for IVP, so we know that this is the time. So at time 0, okay, y is 1. Okay, this is for y1. And for the second condition, we call as y2 at first initial. So how can we determine for the intersection? This is example how difficult IVP. Okay, for the second figure, okay, this is the way how we solve using BVP. Given at initial of x and then end condition of x. So we have x equal to 0 and then we have x equal to L. Okay, when we have initial and end condition, so we can explore the condition in between. What is the x value? Okay, in the middle of initial and end value. Okay, and of course we know the value of L. Okay, value of y at x0. So you have this y0. You also can know the value for yl at x equal L. It means yl. Okay, you must write. Okay, you must write. There's two conditions. Okay, these two conditions before you start. Okay, solving your problem using BVP. Must write, compulsory. This one, yeah, these two conditions for BVP. Okay. This is example for BVP. So we have heat transfer coefficient. Okay, we have heat transfer analysis at x equals 0, at x equal to L. So we have temperature 1 and we have temperature 2. This is also example for boundary value problem. Okay. So two methods that we can use to solve ODE BVP. First method is shorting method. Second method we call as replacement using finite different method. So where we can know this finite different method? So this is from topic 6. Okay, from topic 6. Finite different approximation topic. Okay, so you need to familiar lah. You need to familiar. This skill you must carry on until BVP. Okay, until BVP. Okay, so we need to see how shooting and finite difference solve the BVP problem. Okay, first, shooting method. So shooting method is a method for solving a boundary value problem by reducing it to the solution of the initial value problem. So when you understand that this method is actually reduce the power of the problem, okay, the power of the problem equation to the initial value problem. So it means that it becomes difficult. Okay, it becomes difficult because when you reduce to the initial value problem, you need to use method BVP, IVP. Okay, no longer use BVP. You only start using BVP and then reduce, okay, reduce power of equation to become initial value problem. When you are ready, your equation is initial value problem, so you need to solve using initial value problem method. Okay, what is the two method for initial value problem? First, Euler. Second one, Runge-Kutta. Okay, Runge-Kutta. The procedure is similar to the Newton-Raphson method. So it means that Euler and Runge-Kutta used for finding the root of equation in several variables. The method is called shooting method because a trial and error approach is used to solve the problem as a series of initial value problems. So for example, you have second order and then you reduce to the first order. Okay, so this is a step how we use shooting method. So first step, you have second order BVP and then you declare, okay, your condition for solving the BVP and then you define the variable. It means that yx, what is the variable involved for your problem, and then restate as set a 2 of 2 first order BVP. So you need to have two sets. You need to have two sets of question first order. Okay, and then step number 4, start guess the initial value. So it means that you guess x equal to 0 and so on. And then step number 5, solve using fourth order Runge-Kutta. Okay, using fourth order Runge-Kutta or Euler. Okay, or Euler. Okay, so this is an example. How can we understand we want to separate two equations first order? So you imagine that this is second order. Okay, so second order must be reduced to first order. Okay, reduce first order. So this is a step. Yeah? You see, reduce first order. So then, define the variable, restart as 2, a set of 2 first order. So you must reduce. So first order, you guess dt over dx equals z. First equation first order. And then second one, you differentiate this one, become second equation. This is a second equation. Okay. After that, you use try and error. So try and error. So this one, start guessing the initial value, try and error. So you can start with the, okay, x equal 0. And then you repeat all the computational process. After that, the final one, you can obtain your result. Okay. Anyhow, okay, don't worry. So shooting method need to have a very long process. So for your test, so it's actually consume time. So usually we not test student with the shooting method. So we just want student know what is the alternative method. If we not use finite different method, we can use shooting method. Okay, we can use shooting method. Any question regarding shooting method? Any question? Okay, shooting method, we never have experience to test student during test because it consumes a lot of time to solve by using shooting method. Okay, so now I would like to focus for BBP is using finite different method. Okay, finite different method. The most common alternative to the shooting method is using finite different approaches. In this technique, finite divided different are substituted for the derivative in the original equation. So original equation is ODE. Okay. So you use finite divided different, substitute in original equation. Okay. Thus, a linear differential equation is transformed into a set of simultaneously algebraic equations that can be solved using solution of simultaneously linear equation. So you know that the finite different approximation using central different finite is this formula. Okay. So please have a look your topic 6. Okay, please all open your module. Topic 6. Please search using central finite difference. Okay, second order derivative. This is second order derivative. Okay, open your module or your textbook. Topic finite different approximation. Okay. And then search second order derivative using central finite difference. Okay, this one. Okay, if you're using your module, page number 19.3. Okay, page number 93. Okay, page 93. Okay, page 93. So you see, second order derivative f double prime x, okay, f double prime x equal function xi plus 1 minus 2fxi plus fxi minus I divide h square. Same, eh? Same, eh? Aizat? Aizat? Betul, eh? Okay. So, for boundary value problem, okay, do not use forward or backward. Directly apply second order derivative using central finite difference. You always need to use this formula. Okay, this formula for second order derivative. If question give you first order derivative, yang mana nak kena guna? Arif? 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 Afiq?
Ya, Doktor.
Okay, Afiq. If question give first order, where we need to use the formula?
Second derivative.
Yeah?
Second derivative.
No, first order derivative. Which
First
one
order.
you need? Yang mana? Cuba sebut formulanya.
Fx. X function X first derivative betul?
Ya, first derivative. Jika
F.
soalan first derivative.
Oh, kalau second, ambil yang second derivative betul?
Ya, kalau second terus ambil second derivative. Kalau first
Oh.
order terus ambil first derivative. First order derivative yang mana?
Yang kalau dalam modul page 93.
Okey, yang mana formulanya sebut?
Yang F prime function X prime equal to function xi plus 1 minus function x I minus 1 over 2h.
Ya, betul. Okey, betul Okay. So please use only central different approximation formula for error OH square. Tak payah pakai OH4 tu ya. Memang yang itu je. Okay. To solve the finite divided different approximation for second derivative or first derivative and so on is used. Okay, using finite. Okay, example 9.2. How can we use finite different method? Using central finite difference. Okay. Find the solution of this linear equation using the finite difference method. So most of the time your test 2 question is directly student need to use finite difference method. Okay, this is the easiest way to solve the problem for BVP. Okay. So y double prime plus 1 over xy prime minus 1 over x squared multiply y equal 3. Okay. Given the condition of boundary. First condition, y at x equal to 1 is equal to first condition. Second condition, y at x equal to 2 equal 3. Condition number 2. Okay, for boundary value problem, you must write 2 conditions to make sure that this is boundary value problem. If you only write 1 condition, I give you wrong. The 0 for declaration of 2 boundary condition. Okay, compulsory to write 2 boundary condition for BVP. Okay. And then for x equal to 1, increment for each 0.2 until 2 with finite difference method. Okay, this is example directly mentioned using finite difference. If task usually we not mention to student, how can we solve this problem? Student need to decide by themselves. Okay. Okay. So how can we do this example? Asrul Hafizi. Asrul Hafizi. Okay, I directly jump to how can we solve using finite difference, yeah? Because this boundary value problem is easy implementing the solution. Asrul Hafizi. J Ketong. J Ketong, Eunice. Eunice. Right. Fakrul.
Okay, Doktor.
Okay, Fakrul. What is the first step that we need to do for this problem?
What second derivative?
Okay, so you want to substitute this one, right? Okay. Can you give me the equation?
Function of xi equal to function xi plus 1 minus 2f two function of xi plus function of xi minus 1 over h square.
Okay. So you just substitute here because you know this is f double prime. Betul, Fakrul? Betul, Fakrul?
Betul.
Okay, so substitute saja ya. Plus, buat je. Plus y double prime. Y double prime. T Hui Feng. T Hui Feng. T Hui Feng. Azmi. Okay, Azmi. Y prime. Give me the equation. Because I want to substitute here.
Y prime x equal to y xi plus 1 minus y xi minus 1 over 2h.
Function x. Y atau function same ya.
xi plus 1 fx I minus 1 over 2h.
Minus 1 ya. Over 2h. Okay, don't forget to put 1 over x. Okay, yang mana tak perlu ganti, tulis saja. Ya. Minus y. Y kita nak buat apa? Y kita nak buat apa?
fx.
Okay, fx I. Okay. Maksud kata, dia adalah di bawah variable bergantung kepada perubahan grid nanti ya. Okay, multiply 1 over x square equal 3. Boleh? Boleh faham? How can I change this one? Siapa tak faham? Tak kan? Okay, please tell me if you not understand. How can I change this one?
Betul. So kita ambil yang second dengan first derivative lah, betul?
Yes.
Kita masukkan.
Yes, yang ini this one is not the first or second. Okay, this one is the original one. Y lah.
Original.
FSI saja. Okay, kita letakkan dia FSI saja. Okay, after that what we need to do? Okay, after that what we need to do? So you must make sure that you draw your grid. This one grid. To feel how can you move first step, second step, okay, move backward. So x plus 1 is actually means you need to move forward, I minus 1 move backward. Kan? Betul kan? Ini you dah memang belajar masa finite different method and you already solve your problem. Okay, so you master lah that skill. Okay. Second step, ataupun you can do this is as first step, yang ini second step. Okay, don't forget to write and draw like this. So you understand that your initial point is number 1, bukan kosong kan dalam problem ni. And your end point is 2. Betul? Okay, and then in between, your increment is 0.2. Increment is 0.2. Okay, so how many times you need to move or jump until you reach number 2.2? So you kena kira lah. So it's actually, okay, B sama je. KH equal to B minus A over 10 Okay, ataupun N equal to B minus A over H. Sama saja. So 2 tolak 1 bagi 0.2. Berapa? 5 kali. Betul? Betul Nakib?
Betul, betul.
Okay, so 5 times. So you put here 1.2. Okay, this is a step size. So you start from 1. So 1.2, 1.4, 1.6, 1.8. Okay, you nampak? 1, 2, 3, 4, 5. 5 point you need to jump. Okay, from initial to the end. Okay, and then the question asks you find the solution of this linear equation using finite difference. It means that you want to know what is the y value. Okay, so here you know y at 1 is 2, y at 2 is 3. Okay, so now what is the value for y at this one, y question mark at 1.2? What is the y value at 1.4? And what is the y value at 1.6? And then what is the value for y at 1.8? That is a big question now. Okay, big question. So you need to solve this as SLE. So in order to solve BVP, you must use chapter 6, finite difference method, and chapter number 3, simultaneously linear equation. Okay, SLE. So if problem statement only matrix 3 by 3, okay, don't use SLE manual method. So please directly use your own calculator for matrix 3 by 3. Everyone know how to use calculator, right? For matrix 3 by 3. Okay, except matrix, big matrix 4 by 4, 5 by 5. Then you need to use SLE method. Okay, SLE method. So based on my experience, previous tests, okay, the question only limit up to matrix 3 by 3, 2 by 2. So make sure you know how to use directly your calculator. Okay, your calculator. Okay, so after you write this one, after you draw this grid line, okay, you must go to the step number 3. So this is step number 1. So this is step number 2. So this is step number 3. Step number 3 is actually change this fxi plus 1 at specific point. Yeah, at specific point. Okay, use at a specific point. Use at specific point. Okay, so start at 1.2. Start at 1.2 centimeter, for example. Okay, 1.2. So when you start at 1.2, your 1.2 is actually your I point. Okay, your I point. Okay, so you need to develop one by one the modeling equation. Okay, I stop sharing. I need to share Microsoft. Mana saya boleh? Share it again. Okay, can you see my whiteboard?
Yes, betul.
Step number 3. Besar pula. Okay, how can we do step number 3? Kan? So this one saya letak kat sini. Okay, nampak ni Okay, so everyone have your own equation just now So not necessary. Okay. So at 1.2 centimeter. So now this is your eye point. Okay, so you need to redo 3 times. So for this one, 4 times. Okay, 4 times lah. Sebab in between just now you have 4 points. Okay. So how? So fxi plus 1. So it means that I 0.4. Okay, 1.4. So you put function 1.4. You put like this. Because I 0.1, I plus 1. So from your initial 1.2, so move forward 1.4. Boleh? And then minus 2fi, 2fxi, so function fxi, so function 1.2. Plus function I minus 1. Okay, plus function I minus 1. So it means that F1 F1 divide H power 2 plus function X I plus 1. So means function 1.4 minus function fxi minus 1. So function 1.
Doktor, bukan
Yes.
yang function 1.2 tu times 2 lagi tak dalam formula?
Pardon?
Yang function 1.2 perlu times 2 kan?
Ini
Dalam
mewakili X. Ini mewakili X. Ulang.
yang in the formula ada 2 times function xi
Oh ini.
for the second derivatives.
Okay, 2 Okay. Ini betul. And then 2H. H berapa? 0.2. Yang ini berapa? Yang ini 0.2 power 2. Okay. Do it one by one. And then this one is 1 over H. Minus function I. So function I means function 1.2 multiply X squared. Okay. So this one simplify. Okay, simplify means you kali lah semua ni. You akan dapat satu equation saja. You put here as equation number 1. Okay. Ini challenging sikit. Okay. Yang mana non value? Yang mana non value? Yang mana non value? Richmond. Where is the non value? Yang mana non value?
X.
Yang mana?
Function
Yang mana?
of 1.
Yes. Function of 1. It means that you tukar kat sini, simplify simplify. So it means yang mana ada nilai, you masuk nilai. Ni 2. Ni pun 2. Okay, boleh faham? So you akan ada tiga unknown. Ini unknown. Okay. Ini dengan ini boleh combine. Okay, ini dengan ini, you kena tengok. Ni ganggu tak? So simplify that one. Simplify. Okay, please simplify. Okay. So when you simplify, nilai, please bring to this side. So this is, okay, AX equal B. So this is a constant. Okay, this is a constant. So bring whatever value constant, bring to your right side. Bring to your right side. Okay, yang belah kiri, semua unknown. Semua unknown. Okay, semua unknown. So dalam modul, itu equation ni, example 9.2 ni. Okay, using module, page number 148. Okay, page number 148. You simplify this one. Okay, you akan dapat first equation. Okay, negative 0.78 y1 minus 1.0833 y2 minus 1.7133. This is the first equation. Okay. Okay. And then continue at 1.4 centimeter. Kaedah yang sama. Okay, then you obtain 0.9286 y1. You jangan confuse ya. Dalam modul dia guna y1. Y1 dekat mana? Y1 is actually y. Y1 is actually y. Y ni lah. Okay. Ni. So dia nyatakan y0, y1, y2, y3. You tengok dia punya ni. Grid line dia. Tengok grid line dia. Jangan confuse. Ya, saya pakai terus f function 1.2 and so on. Okay. So tu dia masukkan untuk value y1. And then dalam soalan ini juga dia menggunakan x sebagai xi. So if your xi condition is 1.2, so you masuk kat sini 1.2 because you nak simplify. Okay? Dekat sini 1.2. At 1.4, your xi is 1.4. So you repeat lah. Minus 2.0204. So you kena buat satu-satu plus 1.0714 y3. Okay, equals 0.12. So this is equation number 2. So you repeat for at 1.6, 1.8. Okay. So when you put at 1.6 cm, okay, you obtain one equation, and then at 1.8 cm, so you have another one equation. So 1, 2, 3, 4. So you have 4 equation. It means that your matrix 4 by 4. Okay, you need to rearrange your all equation to obtain matrix AX equal B. Okay, so matrix A is actually the constant value. So this one, constant value. Okay, so put here constant. And then B is your unknown. So you want to explore what is the value for the intermediate value. Kan, yang ini kan? Intermediate value. So you just need to put Y 1.2, Y 1.4, Y 1.6, Y 1.8 equal B. Okay, constant. Okay, constant. Boleh? Boleh Nakib?
Boleh doktor.
Okay. So you kena buat satu-satu. Lim Huizin, Lim
Yes,
Huizin.
doctor. Yes, doctor.
Okay, after we produce this matrix, so ini kita panggil matrix ya. So you know this is SLE, betul? Lim?
Yeah.
Okay, then if 3 by 3 use calculator, 4 by 4 we need to use what kind of method, Lim? What kind of method? Lim?
Gauss-Seidel.
Okay, you can choose Gauss-Seidel,
Gauss-Seidel.
Jacobi, yes. Yes, that one is more easy compared to use Gauss elimination. Okay, or Gauss-Jordan. Lebih panjang. So ini part by part, okay, 4 by 4, so you need to use Gauss-Seidel atau Jacobi. Okay. Okay, during your rearrange of this matrix, so make sure your diagonal must be same. Okay, make sure diagonal must be same. Ini sama ini sama, same value. If you use module, so you tengok dia susun diagonal dia semua value yang sama. Okay, diagonal value yang sama. So nanti from your equation here, so you akan dapat nampaklah dia value ni. Dia sama kan? Letak dia di tengah. Okay, put as a diagonal. Okay, put as a diagonal. So after you solve this one, so you can dapat y1.2 is equal berapa? y1.4 is equal berapa? y1.6 equal berapa? Okay, y1.8 equal berapa? Okay, so all of this value we call as approximate, okay, approximate value. This is all approximate value. Okay, boleh faham? Then, if you use calculus, okay, this is true value. This is analytic solution. So, always, question asks you, okay, calculate the error. Calculate the error. Calculate the relative true error. Okay, so maybe you need to calculate using calculus to produce analytic solution and then calculate the relative error. So error is true value, okay, minus approximate value divide true value. Multiply 100. Okay. So you dapatlah error. This we call as relative true error. Okay. Here is relative true error. Okay, relative true error. Percentage. Okay. Boleh? Boleh ya? So please go through it again. Example 9.4. 9.2. Okay, 9.2. Okay. Okay, now continue. So settle 9.2. Okay. Okay, so this is the solution. So you must show your grid. Okay, grid. So you must draw this one. So X node, X1, X2, and so on. Okay, you made that this a solution. Okay, so this is example 9.4. Okay, because this is a very easy topic. So you just need to substitute. Okay, simplify the equation. Produce equation, okay, do metric form, use your own calculator if 3 by 3 and last, solve the solution. Okay, solve the solution. Only that, using, okay, solve the solution. Position finite different pin joint support at A and P-roller supported at B is used to carry a distributed load, okay, of 100 Newton per millimeter, as figure 9.2. Okay, so this is the same way. When you receive this equation and there's a problem, so you need to do first, okay, you need to do first step. So please draw the grid line. Please draw the grid line. Okay, so this is all the equation lah. Okay, so please do grid line. Okay, grid line to make sure that how many points that you need to evaluate. Okay, if 3 points, so you know that when 3 points, you must prepare matrix 3 by 3. If 4 points, of course, you need to prepare matrix 4 by 4. And then step size. For this problem, the set size given to us is 250. Okay, 1000 divide 250, so only 4 time to jump. Okay, so point only 3. Okay, so you can change lah. Okay, same way. Substitute this equation into the general equation. So when you have module, so please have a look at the example. Okay, 1.4. Example 1.4. Okay, you boleh tengok. Okay, first, you do grid line. And then second one, okay, substitute. Substitute the central finite difference formula in the original equation. Okay, given the original equation. So if a second order, substitute with the second order. If first order, substitute with the first order. Okay, for each substitution, give 2 marks. So if you have 4 equation, 8 marks. If 3, 6 marks. Okay, you substitute. And then please remark your first equation, remark your second equation, and then remark your third equation. After that, produce your matrix. Okay, so for this example, matrix only 3 by 3. Okay, make sure that your diagonal is same. So for this one, diagonal is -2. Okay, diagonal. After that, you solve for y unknown condition. So y at the 250, y at 500, and then y at 750. Okay. So at the end, you produce your y 250 is about 1.3. Y 500 is about 1.89. And y 750, okay, 1.3563. Okay, this is the relative true error that I mentioned to you. Okay, among the popular questions. So you must have your own value for each approximate value. And then you need to know your true value. If the question gives you the true value equation, so you just need to substitute about the independent value, produce the true value, and then calculate the absolute relative error. Okay, the formula is true value minus approximate divide true value multiply 100. Okay, so this is example 9.5. So it's similar as the previous example. Okay, follow the first step and then change with the finite difference formula and then produce your matrix and then solve the equation. Okay, clear eh? You nampak ni? Dia just substitute saja. Okay. So that's it. This is only for BBP. Okay, this is only for BBP. So any other question before we proceed to see from the previous test 2 question? Ada soalan yang tak faham? So you must understand how to substitute and then to produce your matrix and then using your own calculator in matrix 3 by 3 and then solve the problem. Ada soalan lagi? Kejap je, topik ni memang sikit. And what you need to know for boundary value, you need to have two boundary condition. Okay, if you don't have two boundary condition, you can't solve BBP. Okay, and then boundary value problem. Okay, we also can call this is as two boundary problem. Okay, if you have two boundary problem, then you can call as boundary value problem. Okay, and then what method that you can increase your accuracy using boundary value problem? First method, you can reduce step size. Okay, second method, you can explore the another method instead of finite difference. Okay, the larger the step size, the less accuracy you can produce your solution. Okay, the lowest value for step size, the high accuracy you can produce your solution. Okay, ada soalan? So finish for boundary value problem. Okay, it only covers about finite difference approximation. Okay, ada soalan? So you know how to substitute, yeah? How? I'm trying to searching a previous task. Last assignment about the curve fitting and ni ke? Integration ke? Oh, this is a timetable. Oh, I kena buka e-learning lah. Saya tak boleh download. You all dah tengok kan saya share previous task?
Ada doktor.
Okay. Saya tak ada dekat laptop ni. Saya kena download lah. Check balik.
Doktor nak tanya.
Ya.
Kan kita dah dapat matrik. Matrik tu kita just solve guna calculator saja kan? Tak
Ya,
payah
betul.
tunjuk.
Okay, selalunya test memang you guna calculator sebab masa. So kita akan bagi soalan pun dalam 3x3 maksimum. Okay, itu je. Can someone share? Can someone share your previous test? So saya punya internet loading lambat. Siapa boleh share? I stop sharing myself. Stop sharing. Siapa boleh share?
Sekejap lah doktor.
Okay, cuba share. So the important thing is question number 1. So question number 1 is the combination between curve fitting, numerical differentiation and integration. So I need to explain how it can be, okay, for the combination topic, okay, to become as one question. Okay, please share. So now we would like to fill, okay, how can the question will be? I guess, okay, the pattern quite same. Okay, good. Okay, so everyone can see, yeah, this is from the previous test. So by this time, so we directly run 9 p.m. to the 11 p.m. Okay, we don't have separate time. So this is for the question 1 from last semester. Okay. So you see, okay, given to you table. Okay, table. So this table is actually from the original data experiment. Okay, data experiment. So the distance and the thickness given to you. So you know that this is a y and x. Okay, you can imagine y, x. Okay. So original point, okay. And the experiment was conducted and data in non-dimensionless form. Okay. Note, okay, when you read all the instructions, so please be careful. Okay, for numerical differentiation, use second order accurate formula. For numerical differentiation, use second order accurate formula. So it means that second order accurate, if you use a forward and backward, so you see you have first order accuracy and second order accuracy. So ada table kan? Error OH2. OH2 is actually a second order accuracy formula. So please remark. Okay, please remark. That is OH2. OH2 is second order accuracy formula. Okay, and note number 2. Recommended step size for both numerical differentiation and integration is 0.2. So clearly mentioned, you must use 0.2. Okay, the recommended step size, you must use 0.2 for your curve fitting, for your numerical differentiation step. Okay, it's consistent 0.2 even though your data is random. Okay, faham eh? That is the notes. Question A. From the data in table 1, determine a nonlinear function. Okay, determine a nonlinear function that best represent the experimental data. Please show detail of your calculation. Okay, for this one, so when you see this data, you understand that for distance 0.6, when distance 0.12, okay, the gap between 0.12, and then the point number 3 is 0.38. If it is consistent, so it must be 0.24 and then 0.36. So that is a consistent. However, this is not consistent. It means that random. So when you plot random, so that is the reason why the question wants you to determine the best curve fit line. So best curve fit line is, that is the reflection of the student to choose what kind of function, what kind of method that you need to solve. Okay, so the keyword is when you receive any nonlinear equation with the random data set. So the easiest way, okay, the easiest way that all students, okay, should be known to help you to solve easily is regression method. Okay, regression method. Cuba buka dekat curve fitting. Cuba buka topik curve fitting. Okay, everyone. Open your textbook, open your module. Cuba you tengok balik. Topik curve fitting and interpolation. Okay, sometimes student, okay, during this semester, student really blur. Okay, that is not mentioned what kind of method, but the question requests to determine a nonlinear function. Okay, so this actually is under curve fitting. You must know when you want to produce best curve fit line. Okay, which topic? So you must understand curve fitting and interpolation is basically to produce the best curve fit line. So you have regression and you have interpolation. Okay, two methods. You have regression and you have interpolation. If you want to do interpolation, okay, is actually interpolation. So in between, interpolate, that is the big keyword. So interpolate. Okay, so it means that your point must be not random. Okay, you can make best curve fit line. if your data random, so you must use regression. Okay, so you must use regression. So how can you use regression? So go to the least squared regression. Okay, because your test is open book. Okay, not closed book. So go to the least squared regression. Okay, and then again, least squared regression, dia ada tulis The method of least squared is a standard approach in regression analysis to approximate the solution of overdetermined system. Overdetermined system. So kalau you punya eksperimen tu random banyak, please use regression method. Okay, jangan guna interpolation. Interpolation tu yang sikit-sikit boleh guna interpolation because it is much tougher than regression. Okay, so you use least squared regression. So where you want to use? Linear, you have linear regression, you have polynomial regression. So polynomial regression, you have from second order regression, third order regression, and up to M order regression. Still remember or not? Okay, up to M order regression. So dekat sini, you need to sketch, okay, to give idea to yourself is actually, okay, how much order for this question. Okay, during this test, ada student yang clever sikit, they try buat dot point, and then it seems like second order. Second order. Tak percaya you try plot, okay? You draft plot je. So second order. If your random data looks like a second order, you use first order. So for the purpose of test 2, so kita bagi salah sebab you tak faham, okay? And error you become big. Okay, so you must use second order. When you use second order, we give you full marks. Okay, so second order, second order. So how can you use second order? So please go to the example 5.2. Okay, remark semua dekat latihan ini. Soalan A, tolong buat latihan example 5.2. Itu jawapan dia. Okay, 5.2. Buatlah berdasarkan data yang you ada. Okay, dan ada soalan? Ada soalan? Ada tak bidang lain ya? Pada?
Macam mana kita nak tahu guna second education?
Sketch data ni. Cuba you sketch data ni. Cuma laju-laju lah. Okay, you sketch ni macam ada curve. Then you decide using second order. Okay, that is the easiest way. Ada juga student yang pakai interpolation. Kita tak bagi kosong, kita bagi markah. Tapi because of interpolation very long. Sebab interpolation ada berapa method interpolation. Interpolation kita ada linear interpolation, kita ada quadratic interpolation, kita ada Newton divided different interpolation. Okay, if you use quadratic interpolation, so banyaklah function ni semua. Then student, okay, make mistake, dia tak dapat sampai final best ke fit line dia. Itu je, dia salah. Okay, bukan kita tak bagi markah penuh, kita bagi markah. Tapi sebab panjang sangat jalan dia, sebab dia kena guna second order. Second order interpolation. Okay, quadratic interpolation. So dia buat tersalah. Okay, so kuranglah markah dia. Itu saja. Okay. So memang the best way yang you nak selesaikan ini adalah second order regression. Okay, cuba semua plot. Okay, roughkan benda ni. Okay, you akan nampak dia seolah-olah second order. Ada lagi soalan lain? Okay, B question. B. Based on the function developed in part A, so you ada satu equation, kan? Y equal to bla 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 bla. Okay, you dah dapat lah Y equal to semua lah. Okay. Yang A tu you prepare equation dia je. Y equal to 2, 4, 5 X squared plus Y plus 5 X, for example. Okay, so B ni dia lebih detail. So B is actually from part numerical differentiation and integration. So you must understand when you do integration, it's actually area under the curve. when you do differentiation, you explore about the slope. Faham tak? When you use regression, okay, when you use interpolation, that is exploring unknown point. Exploring unknown point. Okay, that is the purpose. So, B1. Provide the missing value in table 2. Okay. What are the value of y at x equal to 0.2, 0.6, and 0.8? Okay. So, it means that you have the basket fit line. So, you just substitute. Kan? Sebab you punya basket fit line tadi adalah equation y equal to apa-apa x, apa-apa x. So, when you want to produce missing value is actually unknown point. So, unknown point pada x yang diberi. X 0.2, x 0.6, x 0.6, x 0.8. So, masukkan setiap satu. Mula-mula test pada 0.2, lepas tu test pada 0.26, lepas tu test pada 0.8. That is the y value. That is the y value at x 0.2, 0.6, x 0.8. Faham? Faham? Okay, faham itu je, senang je. Banyak sudah salah tak faham. Okay? And then the number 2. Determine the slope. Slope. You know slope apa tadi saya kata? When it comes to the question slope finite different. Slope mesti finite different. Okay? Determine the slope at x equal to 4, x equal to 0.4, and x equal to 0.8. Okay, using numerical method. Bila you dah ada tadi equation tadi, okay, so bila you dah tahu ini numerical differentiation, so dia ada trick dia. You pergi dekat numerical differentiation, okay, you dah tahu kalau you nak cari slope, you mesti differentiate once. Betul? Betul? You nak differentiate mesti once. Kalau dia tanya slope, kalau dia kata double slope, you kena differentiate 2 kali. Betul? Tu trik dia. Saya nak tanya siapa? Wee Jun Ki. Yan Zinji. Teh Chia Jin. Ti Bai Hong. Tak ada semua ni? Chi Kai Wong. Mana semua ni? Rizwan.
Doctor.
Rizwan Yaakob.
Yes, doctor.
Okay, Rizwan.
Hmm.
B number 2. B2 Roman. Okay, kalau kamu tengok soalan ni, kamu nak guna method mana? Dia kata using numerical method.
Numerical integration.
Ha?
Soalan B2
B2.
Numerical differentiation.
Yang mana? Cerita dengan saya. Yang mana kamu nak guna ni?
Forward second order ni.
Forward yang mana?
Ya.
Ini pun cabaran ya. Student somehow dia tak tahu macam mana nak pilih. Pak Rizwan, saya nak tanya kamu.
Secondary forward differential approximation.
Dan pada
Second derivative forward difference method.
kenapa kamu nak guna second derivative?
Ha?
Kenapa kamu nak guna second derivative?
Oh, dia linear. Kalau dia linear, linear. First order forward difference formula kalau ni.
Okay. Kenapa nak guna first order? First order difference ni.
Fraction dia
First
linear.
derivative. Kenapa kamu guna first derivative?
Sebab dia punya increment dia linear.
Kan? Sebab you need to determine slope.
Tapi kalau slope boleh juga pakai second order. Log dia boleh tak boleh?
Kalau slope second order jadi apa?
Kalau slope second order.
Soalan ni distance kan? Okay, you ada equation tadi yang atas A tadi, y equal to apa-apa x. Okay,
Okay.
so that is the original equation. Okay, kalau kita differentiate distance dapat apa?
Differentiate distance velocity.
Ya?
Velocity.
Okay, velocity. So dalam kes ini, slope. Okay, slope is velocity. Sebab you tengok, okay, bila you buat ni mungkin kadang you macam tak sure kan. Cuma you tengok soalan nombor 4 tu. Determine the second derivative. Betul? So bila you tengok soalan nombor 4 ni, takkanlah yang slope ni I nak buat lagi second derivative, betul?
First derivative lah ni.
So first derivative. Somehow kadang-kadang kan student dia blur, tolong tengok soalan yang ke bawah dia tu. Dia mesti ada kaitan. Okay, tolong tengok Kalau tak you macam sayang benda ni senang sangat. Okay, so now
Kita tu boleh identify ke what type of order nak kena pakai direct daripada dia punya function tu.
Macam contoh tadi you kata you nak guna forward, betul? Forward first derivative kan? Okay, forward first derivative dalam kes ini fxi plus 1. So kalau pada x 0.4 maksudnya nilai 0.6 ada. Minus fxi. So nilai 0.4 ada. So boleh pakai forward. Itu maksudnya. Lepas tu katalah kawan kamu nak pakai backward. Okay, backward. Backward first derivative fsi ada value. Fxi minus 1 ada value 0.2. Ada value kan? Sebab you dah kira dekat nombor 1 tadi. Betul? Yes, boleh. Lepas tu tengok pula central. Pun ada value. Boleh. Sebab tu dia tak cakap guna numerical method forward ke backward ke. Dia cakap using numerical method. Okay? So you can use these three method. Pilih salah satu. Jangan buat tiga-tiga. Habis masa. Okay? So you buat 2 kali. Okay. And then 0.8. Okay. 0.8 pun boleh guna. Ya. Central pun boleh. Forward pun boleh. Backward pun boleh. Sebab dia nilai yang di tengah-tengah. So adalah. Okay. Soalan nombor 3. Fatin. 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 T Hui Fong. Oh, Yan Jinji, I can't hear you. Okay, I can't hear you. Chi Kui Tung. Chi Kui Tung. Arif.
Ya,
Okay,
Doktor.
Arif, number 3, B3.
Pakai numerical integration.
Okay, numerical integration. So you nak pakai apa? Numerical integration apa ni? Dia ada banyak kan? Apa paling senang lah yang Arif nak pakai? Pun dia cakap. Using numerically, okay? The total area under curve numerically. Apa? Arif nak pakai apa?
Trapezoidal.
Okay, trapezoidal. But how about the equation? Equation mana nak pakai? Dia mesti function kan? So function yang mana? Dia kata daripada
Function.
0 kepada 1. Distance tu lah 0 kepada 1. Using recommended set size. What happen if we reduce it? Apa? Ari nak pakai apa? Ari dah kata Ari nak pakai trapezoidal rule. Okay? Equation yang mana? Equation mana nak pakai?
Equation yang regression. Kita pakai daripada regression kan? Bukan.
Ya ke?
Yang
Ya ke? Ingatlah. Kalau Arif pakai equation yang regression tu, dia dah potong habis. Random datang. Boleh.
Kena pakai yang asal
Okay.
kan?
Kena pakai yang asal. Tapi perlu ke kira balik? Sekarang ni, Arif dah ada thickness Y tu value apa Y tu ya? Apa value
Oh,
Y?
kiranya kita pakai tambah daripada Y tu je lah. Maksudnya
Ya,
Y tu kita tambah.
ya kan? Tu je lah. Okay, faham kan? Tapi you gunalah trapezoidal punya. Trapezoidal punya mana formula dia Arif?
Integration equal to integrate B,
Ha?
A. B dengan A tu kosong dengan 1 lah kan?
Betul. Satu tolak
Ah,
kosong lah. Satu tolak kosong yang silap. Bagi N. N tu apa? Berapa kali N? Sebab dia kata guna 0.2. Kan? So berapa kali N Arif?
5.
Ya. Okay. Lepas tu? Kali
Lepas tu
dalam kurungan besar?
dalam kurungan besar F1, F naught
Yes.
plus F2, F1 plus
Itulah semua lah.
pula Fn.
Semua yang ada tu dah. Kan tadi dah cari.
Aha.
Sampai nama. Pakai je lah. Tambah saja.
Kena bagi 2 juga
Yes. Jangan.
Okay.
Formula tetap formula. Okay. If you use trapezoidal, you guna you punya formula trapezoidal. If kawan you pakai Simpson, reflect kepada Simpson punya formula. Boleh faham? Senang aja soalan ni sebenarnya. Tak payah nak patah balik pusing kira semua ya. The best way you need to understand the fundamental. Soalan nombor 4. Okay Arif, good. Soalan nombor 4. Double. Siapa yang belum saya faham? Afiq.
Ya, doktor.
Okay, number 4. Determine the second derivative value at x 0.6, 0.8. Okay, yang ni nak guna formula mana? Yang tadi what happen when you step size. So you jawab lah. Jangan tak jawab lah, tak ada markah. Okay, when we reduce step size, the accuracy will increase. Okay, accuracy will increase. Guna apa?
Guna forward boleh? Forward.
Forward second order. Okay,
Forward second order. Bila dia sekejap
Dia dah pesan guna second order accuracy. Okay, second order accuracy.
Sekejap. Forward second order derivative. Function of s equal to function of xi plus 2 minus 2 times function xi plus 1 plus function si divide by h square.
You guna central?
Tak, guna forward.
Forward, kalau forward second order derivative dia, second order accuracy dia bukan itu.
Function dalam buku ni tulis function si plus 2 minus 2 times function si plus 1 plus function si bagi dengan h square.
Ya betul, tapi yang itu bukan second order accuracy. You kena ingat, ayat-ayat awal-awal soalan ni dia dah mention, for numerical differentiation, use second order accuracy. Second order accuracy, saya cakap tadi, OH squared. Yang you buat ni OH saja.
Oh, yang bawah dia. Yang bawah
dia. Okay, yang bawah dia. Tu kena faham ya, second order accuracy. Second order accuracy different dengan second order derivative. Second order derivative double prime. Second order accuracy OH power 2. Okay?
Okay.
Okay, Hafiz. And then, ada student dia bijak lebih lagi, dia tak pakai forward dengan backward sebab panjang. Dia pakai yang mana, Hafiz?
Ya.
Kalau you perasan, bila you pakai higher order accuracy, forward dengan backward panjang. Boleh
Ya.
kesalahan. So, you boleh
So,
pakai central. Okay,
central,
different. Yang first tu, dia adalah OH square. That is a second.
yang central ni.
Pendek kan.
Pendek.
Ya, sebab central different dia ada OH power 4. That is a high level. High level lagi. Kita jangan pakai. Okay, kita jangan pakai. So you kena faham lah. Ya, how the curve fitting, integration, numerical integration, numerical differentiation, okay, is combined for one question. Okay, boleh faham? Boleh tangkap? Boleh dapat idea? Ada soalan? Ada soalan? Ada soalan?
Tak ada doktor.
Okay, so hopefully you kena ingat you kena ambil dia punya fundamental dia. Curve fitting and interpolation to produce equation. To produce best curve fit line. To produce best equation for the random data. If random data to produce best curve fit line easily use regression. Use regression. Or else you can use interpolation but be careful. Okay, hati-hati sebab panjang method dia panjang. Numerical differentiation, okay, you can determine all the first order derivative and second order derivative. That is from the original equation. When the original equation, you differentiate once, you obtain first derivative. From the first derivative, you differentiate it again, so become second order derivative. Itu. Okay. So area under the curve, it means that the value of y is actually curve fitting. Okay, the value of the function for the curve fitting, okay, is actually the approximate. If you want to determine the numerical differentiation exactly using your random data, so no need to use curve fitting. So it's actually the value under the curve, y value is actually the actual area under the curve. You just tambahlah value y tu. Okay. Jika tidak memberi value of y, so question also boleh beri y equation. So daripada y equation tu, you kenalah menggunakan substitution, add the value for the x to obtain integration. Tu kita ni you kena tengok balik macam mana integration kalau daripada equation given. Okay, yang ini dia tak ada bagi equation. You produce best curve fit line, so you tak boleh kira dia sebagai numerical differentiation. You kena directly apply daripada y value untuk numerical differentiation. Okay. Okay, soalan kedua. Boleh sharekan soalan kedua? Siapa ada? Okay, terus Oh, ini set A, set B. Soalan kedua ada. Okay.
Ini ke tu?
Okay. You are asked to design a soft closing sliding door. Okay, as shown in figure below, this device consists of the spring and air damper where one end is fixed to the wall and another end is fixed to the door. Okay. This device closes the door automatically when someone releases the door with some distance from wall. Let the movement of the door after touching the soft closing device represented by a second order motion equation in as below. So you tengok equation tu kan? Lagi naik atas. Okay. Whereas is the distance of the door from wall and 0 at the wall. Naik atas lagi. Okay, dia dah bagilah condition relation tu. Ke atas, ke bawah, sorry. Okay, given value M, C, K and so on. Lagi, seterusnya. Soalan dia. Okay, given the spring constant K is 10, damping coefficient C is 8, mass of the door is 2. and the door is realized from static at the distance from wall equal to the 0.5 meter. Nampak? Okay, so now when student receive this question, okay, that is not mentioned about the IVP or BVP. So student need to know this is IVP or BVP. Okay. So first question, convert the second order motion equation into first order differential equation. Okay, macam mana you nak convert ni? Macam mana nak convert ni?
Message.
Okay, so this is the way how the shooting. Okay, how the shooting convert, reduce second order to the first order. So yang ini you kena okay buat dummy macam yang tadi yang saya ajar. Okay, explain how do you distinguish the difference between initial value and boundary value, and then identify all, if any, all initial value or boundary value for this problem. Okay, so how can you distinguish this is an initial or boundary? Macam mana? Saya dah ajar. Dia mesti spesifik. Okay? Dia mesti spesifik. If specific, that is a boundary value problem. If not specific, that is the initial. Okay? So for this problem, kat mana spesifiknya? Ada ke tak ada? Dia kata initial and end. Initial and end. Where is the location for the specific point? Ada tak? Ada tak ada? Huh? Arif ke mana Arif?
Ya, doktor.
Okay. This problem, specifically or not?
Ada sebab dia cakap 0.5 tu. Kot.
Okay, where is the location for 0.5? And the door is released from the static at the distance from wall equal to 0.5.
Maksudnya macam mana?
Macam mana ni? Confused ni. Ni initial ke boundary? Ingat for the initial, so you actually
Dia kena ada dua.
okay, dia kena ada dua boundary yang mana kalau boundary value problem is actually need to know the actual condition for boundary and value tu pada dependent tu berapa nilai dia. That is a boundary. Okay. And then initial. Dia cakap mula hujung. Tapi hujung tu value dependent dia tak ada. Tak ada, not specific. Okay. So this is a claim as initial. Okay. First soalan. Cuba go balik kat soalan. Okay, tengok ni. Ni kan. Mula hujung. Mula hujung. Dia nak explore tengah-tengah ke? Not interest. Okay, for initial not interest. Okay, not interest. So not specific for dependent value, not interest. So this is initial. Okay, tengok. Tengok atas sikit. Tengok soalan atas dia. Okay, dia cakap, you are asked to design a soft close sliding door. Okay. This device consists of spring and air dampen. Okay, where one end is fixed to the wall and another end is fixed to the door. So dua-dua ni fixed. Okay, this device close the door automatically when someone relays the door with some distance from wall. Dia cakap some distance from wall. Okay. So, ujung-ujung fix. Apa yang berlaku tengah-tengah tu nanti kita tengok. Okay, so turun ke bawah. Okay, so turun ke bawah. Okay. So katalah student dia jawab, explain how distinguish. So here you guess boundary value problem. Contoh lah, okay. You macam confused lah, ini boundary value ke. Tapi yang susah masa semester ni, sebab it's a different day, kan? Different day lah. So dia tak dapat ke semua soalan. So dia tak boleh nak agak yang nombor 3 dia tu adalah boundary ke initial. Okay, dia tak dapat nak agak. Macam kamu ni, kan? Macam kamu ni, nanti ikut time. Dia tak dapat juga tengok soalan tu. So you kena faham betul-betul. So katalah you terguess yang ini boundary value problem. Okay, and then identify all, if any, all initial value or boundary value for this problem. So bila you guess boundary, okay, bila you guess boundary, so you kena buat two condition of boundary kan. You kena tulis macam y x, when x equal to 0, y berapa? Y berapa dalam kes ni? Dia bagi ke? 1, 0. Okay. Katalah you buat dia kosong lah sebab you confident this is a boundary value kan. So you buat kosong. Lepas tu y equal to 0.5. Satu tadi pun dekat fix juga, yang satu ni pun dekat fix juga. So y dia berapa? Kosong juga. Kosong. Dia pun berpula kosong. Tak boleh ya? When the problem statement not mentioned about the dependent value is a 0, is a 1, that is not a boundary value. Kalau boundary value dia kena mention clearly because you need to substitute back using a finite difference. Okay, using a finite difference. Okay, then you boleh kata dia adalah boundary value problem. Okay, boundary value problem. Oh, mak ngah ada kelas. Tapi boleh tengok je lah. Okay, mak ngah ada kelas. So, okay. Boleh faham? Boleh faham And then soalan C. Select the first order accuracy. Numerical differential method. Okay, which can be solved using ODE. Okay, A is 4 simultaneously and then write down the numerical equation. Okay, when come out with the first order derivation. So from the boundary value problem, when we reduce first order, so it's actually using initial value. Still remember just now, I mentioned to you when you want to reduce undershooting method, you need to solve using first order accuracy. So when you solve first order accuracy, so it's actually the initial value problem. Okay, you never use a boundary value problem to solve. Okay, you cannot solve using boundary value problem. Boleh beza So then D, calculate the distance of the door from wall. Okay, from wall second after release using the equation for derived in C. Okay, after C, you prepare the first order equation and then you must solve for initial value problem. So now you can use Euler or Range-Kata. So most of the time students use Euler method. Okay, Euler method. So the easiest way use the Euler method. Okay, and then proceed to the E. Given the exact solution of the door 0.5 second after release equal to 0.3379 meter. Okay, calculate the true error. So true error is basically true minus approximate divide true value. Okay, and then state two solutions that can be used to improve the accuracy for the estimation. So maybe you can choose fourth order Ranskata. Okay, fourth order Ranskata method. And then reduce step size. So that is a two-way solution. Okay, ada soalan? Any question? Okay, ada soalan? That is a second question. Yeah, second question, IVP. Clear. How can we identify this is an initial value problem? Ada soalan, Nakib? Nakib?
Ya, tak ada doktor.
Tak ada, right? So you understand, the difference between IVP and
Yes.
BVP, they are the value for defect.
But you need to check whether is it
Yes, pardon?
Yes, yes.
Pardon? Ada soalan? Tak ada, okay.
Tak ada.
Continue. Question number 3. That is the last question. Okay. So most of the time, okay, students believe that the question number 3 is actually BVP. Okay, BVP. How can we understand this is a BVP? Easy way. Okay. Question 1 can be used to model the deflection of the sailboat's mass subject to the wind force. Where Fz equal to wind force, E is a modulus of elasticity, L is a mass of length, and I is a moment of inertia. So given the equation, this is a second order derivative equation, okay? And then give the value for the Fz. Okay. And then the question, use the appropriate numerical method to find the deflection. Okay, y at z equal to 7.5, 15 and 22.5. So it's very specific. Okay, you need to explore in between. Okay, in between the value 0 to 30. Am I right? Am I right?
Yes.
Okay, so that is a specific point. Okay, believe this is a BVP. Okay, just now IVP. Okay, just now IVP. And then you just continue using appropriate numerical. So substitute your second order using central finite difference. Okay, central finite difference. And then after you substitute, and then you try produce a 3 equation for modeling equation. And then you produce your matrix, then solve the matrix. Then you can determine the specific value for the Z. And then you can proceed to the next question. Okay, this problem can be solved using shooting method. Explain the algorithm. Okay, explain the algorithm to perform the calculation for shooting method. Okay, so this may be this time. Okay, we not request student to explain the algorithm and so on. Okay. So you must need to understand, yeah. You must need to understand, yeah, algorithm for the first order. Only to reduce the second order to solve using IDP. That's it. Okay, that's it. Get off direct using main equation. Second order you ganti dengan central finite difference. So macam biasa. Okay, any question?
Doktor,
Yes.
bezakan IVP dengan BVP.
Okay, so to need to understand BVP is specific BVP is ini. Find the deflection y point. Entry point masa ini, tapi dia tak ada nak semua pada jarak itu, jarak ini, that is IDP. Kita nak clear information. Boleh beza? Ada soalan lain? So soalan ni 3x3 je, metrik 3x3 je. Okay, so that's it. So most of the time student akan score test 2. Okay, ada skema jawapan tak saya bagikan? Ada skema jawapan kan?
Ada.
Okay. So you go through it again and again, but anyhow memang takkan sama lah soalan. Okay, please understand the fundamental. Please understand the fundamental. Okay, I hope you will score for test 2. Please understand what is the relation between perfecting, integration, and differentiation. Okay, IDP. So IDP using Euler and Pancharata. BVP only using central finite data. Okay, others please understand all the fundamental. Okay, mark me. Your module, please use a sticky note. This is the method. This is the method. Method is under this page. Because open book test kan, so you boleh buka. Okay, please only use textbook and module. Don't use you punya nota-nota yang saya cakap itu buat apa? Tak payah. Tidak dibenarkan. Okay, tidak dibenarkan. Ada soalan lain? Ada soalan lain maybe regarding a project? So I believe this is our last class. So in the future before you start your final exam, if you have problem regarding a project, so please let me know. So please submit your combination of project 2, okay, between 2 of you, okay, combine jadi satu, ya, complete report based on the rubric. Ada soalan lain? Okay, so please make sure that log your date 17th of June 2021, 9 p.m. to 11 p.m. our test 2 of mathematical method. So we will run same as the test 2, same as the test 1. So you need to turn on your camera, make sure your data is enough, okay, and then make sure you have camera, okay, if you have microphone is better for you and for us, okay. So we need to record all the test date and video recording for the purpose of EAC, okay, application purpose. Okay, if you don't have any questions, so I hope we'll see you on test